Hello, in this video we are going to explore some more features of PSIM. I want to emphasize here is that we don't need to run the simulation every time to visualize our waveform. Once the simulation is completed, we have the data and we can visualize that using the run SimView. So this time I'm not going to run my simulation, I'll just go straight away to run SimView and the data will be displayed in the form of waveform. So here is VD. Now one more thing in the SimView is that we can add some waveforms or subtract some waveform. In other words, we can perform some arithmetic operations on the waveforms. We can scale it by multiplying some number or dividing by some number. So here is the option. I want to use it to demonstrate that the KVL according to this circuit is V in equals to VD plus V out. I want to verify the KVL and I have just added this text. Here is the insert text option. So you can add it for annotation of your circuit. Like comments in programming, you can use this within your circuit to label something or to have some notes. Okay, so how can we confirm this is that let's click this, and here is the area where we can type an equation. For instance, I want to type in V out plus VD and press add. So you can see that we have the waveform, the variable V out plus VD, and I want to compare it against V in. So if I press OK, so here now we have two waveforms. One is V out plus VD and the other is V in, and they are overlapped. That means they satisfy KVL. And if I just click on the V out plus VD, you can see that that waveform will be on the top, and if I press V in, that waveform, the waveform V in will be on the top. So they are kind of overlapped. So this perfectly satisfies our idea that V out plus VD is equals to V in as per KVL. Let's measure the current through diode. So this time we are going to use the current measurement component over here. Just click and we'll bring it to the circuit. So I'll just delete this wire and I'll fit in this current measurement component. Okay, so let's check what's the label. It's I1, so I would label it ID, and that's okay. Okay, now I want to show you that if we go for the run SimView, you can see that the ID is not among the available variables, because we, after making those changes, we didn't run the simulation. So run SimView will only show you the previous data. So let's run the simulation this time, and you can see that ID has popped up. So now we can measure the current. So just to confirm that the peak voltage is, the peak output voltage is 110 and the resistance is 10 ohm. So scaling that peak output voltage by 10, we'll get the peak output current, and that also serves as the peak diode current. So here is the peak diode or peak output current. Here I want to demonstrate one more way to find a differential voltage. For instance, I want my circuit to be clean and the voltage VD is something that I'm not interested most of the time. Maybe during some troubleshooting or maybe some analysis, I might want to visualize the voltage VD. So I don't want to place a voltage measurement block all the time here. Okay, now how to find the voltage waveform across VD, the across diode, is to simulate and let's get rid of the SimView, and here you can see the differential voltage, display the differential voltage. Just select this probe and go to the one of the terminal, the positive terminal. You can see the cursor changes with a plus sign. That means this is the positive end of the measurement, and if we go to the other side, now it says negative side of the probe, the reference side in other words. So you can see the voltage measurement, the voltage across diode. And if we look at closely, it says that voltage of scope 1 minus voltage of scope 2. So when we clicked over here uh, at the anode of the diode, it labeled that net as scope 1, and when we clicked over here at the cathode of the diode, it labeled that net as scope 2. So here you can see this kind of equation which says voltage of scope 1 minus at scope 1 minus voltage at scope 2. So this gives us the waveform, and yeah, if we are done, just press escape if we don't want to measure any other voltage, and we can delete these nets, these labels, once we are done. So this is another way to view your waveform. That was particularly for differential. If we want a node voltage, means if we want with respect to the ground terminal, then we can just go and straight away click on that node and we'll get the output voltage. As you can see, the voltage V out. Okay, now if we want to measure the current, there is also a way to measure the current using the very same probe. Just hover over the device. So for here, if I want to measure the diode current, just click and it says diode current ID. So yes, I want to see the current through diode ID1. Similarly, if I go and click on the resistor, it says whether voltage or current, so I'm looking for current, so